So if you want, I can.
To have like a tutorial,
Because I think it's very important to have this kind of image in mind when we talk about cyclic commutators. So, is there an eraser somewhere? I'll be back. Hold on a second.
To go to Z, you have to go 270 degrees. Either that or the 90. I guess it depends on which angle you define, which one is defined as positive, but I think it's just good to go this way.
Okay. So when you have a still cyclic permutation relationship of the style A, B equals IC, you can represent those density operators A, B, and C in what we call the Liouville space, which is a three-dimensional space in which we have A, B, and C that represent three vectors that are orthonormal. Let's say A, B, and C. Okay. And now, if you have an operator, let's say a density operator, that is, let's say, along A, and you make this guy evolve with the density, so with the Hamiltonian that is along C, what you will observe is a precession. So you'll have a precession of the operator A, and you can write, so exponential minus I CT A exponential plus I CT equals to A cos omega t plus B sinus omega t. This is extremely general, right? Okay, so now let's say that we are making a pulse that is pi over 2. So it means that ICT is actually be equal to I over 2. Okay, so it's going to be sorry, my mistake here. That doesn't make sense. So it means that omega t equals pi over 2, right? So basically it means that you're going to transform A is going to be transformed into B. Right? So now let's apply this to this case where we have two IXSY, is that it? Yeah. That evolves under IX plus SX with a pi over 2 angle. So we know that we have the commutation relationship, which is the following. So it's IX SY. So I'm not writing the commutator with IX because we know that it commutes. And since we're going from Y to X here, it's going to be minus IX and Z. Sorry. Okay? And so we can write this orthonormal thing here, where we have 2IX and Z. Okay? We have our starting Hamiltonian, which is 2 let's write here SX, and let's write here 2IX SY. We are starting, so this is our our initial density operator, and this is our pulse. Is that true? Excellent. Okay, this is true. I made a mistake.
Yeah, I think you can exchange these two. I also don't know if this is actually minus.
It's minus.
Oh, okay.
The permutation is backwards.
It's YX.
Oh, okay, right. Okay, never mind.
That's
then
weird.
your picture should be right.
It's weird because I was expecting. So we're doing a pi over 2 also means we're going pi over 2 in this direction, and I had a sign problem.
You switched where the x-axis is going the other direction or something. If you switch those two axes, I think you're fine.
This guy? These two guys?
Yeah. If the axis pointing towards us,
yeah,
that's going the wrong way because it should go into the board.
No.
Doesn't positive usually go into the board?
No. So XY goes along Z. it's right. So it's like if you're using a screwdriver and you're going from X to Y, your screwdriver just goes along Z.
So you're unscrewing it then?
No, you're screwing. So
When you screw
or whether
something,
you're screwing or
it
screwing.
goes this way.
So if you're doing this, it goes this way.
Yeah, it's unscrewed.
No, that's screwing.
Oh, wait, you're screwing something into the ceiling?
Yeah.
Oh.
So I have a sign problem here because then after when I'm going net.
I think if I were looking down with that y-axis would be wrong. If you're looking down on a piece of paper, you usually draw the y-axis going up.
Well, I mean, so I have a sign problem here, but I think you get the idea. What the hell? I hate that.
Hold on, draw like an XY plot, right? Just an XY.
Oh, X, Y.
Now, what would you call Z?
X, Y. I would call Z.
Coming out of the board.
Yeah.
Out of the board.
Yeah, that's what I did.
Now flip that up.
So if you put,
Like if you take
so
that,
you'll have like this.
if you take the board and put it on the ground,
Yeah.
Y is now facing this direction. You have Y coming toward the other direction.
Right. So here I have this is X, Y,
Oh, that's
and
X.
Z.
Okay.
So I have a problem. I don't know what it is. I'm sorry. I'm so sorry.
You sure you're rotating the right way?
I'm sure. Well, no, I'm not. But
I would consider a clockwise rotation to be constant.
yeah, no. Clockwise rotation is not positive. It's negative. Yeah. That's.
Oh, right, because the angle would be
I
like
mean, this is the positive rotation, and this is counterclockwise.
Yeah.
All right.
Well, whatever.
Kind of weird.
Wait. Let's see. Let's figure out let's figure it out without without this guy.
Maybe
false,
you can just invert. Like say you name it a little differently. I don't know. Like name this C. I don't know.
I don't think naming it will do
Yeah,
that.
no.
No, it works. No, that's it. That's so actually it is so 2xy is 2ix and sy is transformed into 2ix instead.
Right.
I'm sure. I didn't make a mistake. Sorry. X. Because if you take just a simple just like the S case.
You're saying it will be positive?
So,
And that commutator's wrong?
no, that commutator is right.
Didn't you get a minus sign with that?
No, the commutator is right with a minus sign.
Yeah.